In this video, we're going to try and figure out what this really is. Now, trying to figure out another way to rewrite this by directly looking at it would be a little bit difficult right away. So what we are going to do is we're going to try and find a way to rewrite this using the fact that we know how to write e to the power of x as a polynomial. In fact, let's start by doing that. And it keeps going on and on like that forever and ever. So this is what e to the x could be written as a polynomial. And so all we're going to do now is just replace x with I to the power of theta and see what happens. So let's just replace x with I to the power of theta. So we replace x with I theta. And so we're going to notice something really interesting that actually happens when we do this. So what we're going to do now is we're going to try and just rewrite I in terms of another thing. Like we know I is just I, but we know I squared, right? I squared is really just -1. And so we're just going to rewrite these imaginary parts into whether or not they're imaginary or real and account for the sign that we get. Like if we were doing I cubed, that's -I, so we make this minus I times theta cubed over 3 factorial. So we're just going to rewrite it like that. So right here we have I squared, which is really -1. So really we're doing -1 times theta squared over 2 factorial, which is just minus theta squared over 2 factorial. Now right here we get I cubed, which is really just minus I. So we're saying minus I times theta cubed over 3 factorial. All right, so we have that. Now we have I to the power of 4. Now I to the power of 4 is just 1. So in this case, it's just plus theta to the 4th power over 4 factorial. Okay, so we have that. Now we have I to the 5th, which is really just I. So we're going to say that this is just plus I times theta to the 5th over 5 factorial. And it keeps going on and on like that forever. So now what I'm going to do is we are just going to group together the real components and the imaginary components. So what will this look like? Well, our real components would be this term, and this term. So we have 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial, right? Right, and so these would be our real components. Now for our imaginary components, we have this, and this. So in this case, we are going to have plus I times, right, I'm going to factor out the I for the imaginary components. So we have I times theta minus theta cubed over 3 factorial, and then plus theta to the 5th over 5 factorial. Right? And it keeps going on like that forever and ever. So here's the thing. This looks awfully similar to what we saw for the cosine of theta, right? And this looks awfully similar to what we saw for the sine of theta. The thing is, we are continuing to add more terms. But where are we adding terms? Well, notice how when we keep adding more and more terms, it's going to switch between real and imaginary as we keep adding more terms. Because if we have I squared, that's a real number. If we have I cubed, that's an imaginary number. If we have I to the 4th, it's a real number. I to the 5th, imaginary number. I to the 6th, real number. So it's going to keep alternating between real and imaginary parts that we get over here. So that means there's going to be a continuation of things that are added here and a continuation of things that are added here. Now it turns out that if these real and imaginary components parts keep adding, then what will happen is more real components are going to be added in an alternating sign way, right? This will be an alternating sign here. And more real components will be added with the same pattern that we see. And the same thing occurs for i's, right? There's going to be an alternating sign, and things will keep following the same pattern. As a result, this means that what we have here is equal to the cosine of theta, because that's what we saw in the previous video when we figured out cosine of x as a polynomial and sine of x as a polynomial. So really, this is just the cosine of theta. And right here, we saw from the previous video, when we found sine of x as a polynomial, that this is just the sine of theta. So e to the I theta is equal to the cosine of theta plus I times the sine of theta. And so this is how we rewrite e to the I theta into something new.